Good evening.
Hello, hello.
How are you doing?
I'm doing great. Please excuse my attire and background. I think I explained this in a previous week, or that might have been the recording that we lost. But me and my wife are renovating a house, and we don't have proper heating yet, so it's a little bit chilly where I am.
Yeah, so we did lose a recording. Unfortunately, last week we had a call and only I was on it, and Jesse's voice didn't even make it. And so I decided not to upload that. But fortunately, the only topics we discussed were updates, and we were thinking that we can just rehash those topics during this call. So, in terms of updates, for the longest time, we were working on the transaction programs, which are part of consensus logic. Those are now finished. Hooray! We have all the transaction programs that we want, or rather, that we anticipate before launch. And now we're busy integrating the transaction initiation pipeline with the rest of the client. And so why are these transaction programs such a big deal? Firstly, why did it take so long to write them? Well, it's because they are written in TASM, which is short for Triton Assembler, meaning that it's a custom assembler language for our virtual machine, Triton VM, which means that you get to produce a proof whenever you run the program. And that's the whole selling point. You prove that you are signing off on the UTXOs that are being spent in the transaction. You prove that no inflation is taking place, even though the amounts are hidden. You prove that you are not double spending UTXOs, even though you are hiding which UTXOs you are spending, and so on. And then there's a little extra complication because it's also possible to update transactions that live in your mempool, because suppose you have a transaction living in your mempool and then a block comes along. The transaction's proof is tailored to the most recent block. And so if a new block comes along, that would invalidate that transaction's proof. And so you want to avoid that, or you want to have a way to still get that transaction confirmed, assuming, of course, that it's
But
not
why
double
why would it
spending.
be why would it be hanging around in your mempool?
Oh, because the miner did not select it for inclusion in their block for whatever reason. Maybe other transactions had higher fees or higher fee ratios, rather, and so the miner rationally decided to prioritize those other transactions, or because the miner simply didn't know about it.
Okay.
On Bitcoin, there's generally speaking a full mempool. Well, I shouldn't say full, but the mempool is rarely cleared, as is because not all transactions get confirmed. They can't because there's a block limit, and miners have to pick and choose, and they choose the transactions with the highest fee to byte ratio.
So are they? Do they get periodically just sort of emitted to the network from the mempool?
Every node on the network has their own mempool. So when I say the mempool, it's really only relative to one client.
Hmm.
Are they emitted? I guess you could program or configure your node to periodically re-emit the same old transaction if it hasn't been confirmed in the meantime. And that should work on Bitcoin. That should work on Neptune as well. But I don't think it's a good idea to bake that into the protocol.
Okay.
Seems superfluous. Anyhow, one of the complications in regards to transaction programs is we want to be able to update proofs. And that's the first time that recursion really rears its head, because you need recursion for that. You need to verify that the old proof was valid, and then the new proof basically says there was a proof that was
That was
valid
valid.
for this transaction. And the reason why verifying the new proof is just as fast as verifying the old one, even though you're accumulating a lot of history in the meantime, is because we have succinct verification. The verifier takes less time than verifying the claim naively.
Okay, but why are we talking about this again? What's the broader context?
The broader context is giving an update about where we are. And where we are is we just finished all the transaction programs. And so it is a big deal, and it is sufficiently big for us to launch a new version of testnet, because we want to test this stuff in production, or as close to production as possible prior to launching.
Yeah.
And so that will be coming along very soon. Integrating the transaction initiation pipeline with the rest of the client is going to take a while, because the rest of the client has evolved. The code base, I should say, has evolved in the meantime, and now we have to play merge, which is a fun game. We have to merge two divergent Git histories, basically, and this is rather intense because we were working on two separate branches for quite a while. Yeah, and so the message is watch out for a new version of testnet, which will be along very soon. Hopefully by next week we will have launched testnet, but I tend to be overly optimistic about that sort of prediction.
Okay. And what's left? How does
What's
this...
left?
Yeah.
So we have a very good idea about what we want for transactions, but what we want for blocks is a little fuzzier. It certainly looks as though we will be launching without recursive verification of blocks. This is because we've learned that writing these consensus programs can take a long time, and also we observe, or we decided that scalability, which is what we would achieve with recursive block verification, is really only an issue if there is a lot of traffic and demand and users. And until we have that, we could get away with slightly less scalable architectures. And we're definitely going to build it. It's just not going to be there at the time of launch. And so if we're not going to spend time on block consensus programs, and the transaction consensus programs are already finished, well, then there's not that much left between where we are now and mainnet launch. Mostly client programming. We have a lot of loose threads to tie together, and it's application programming from here on out. It's not consensus it might be a little bit of consensus programming, but not a lot.
Okay, so no major, no topics with major complexity between here and mainnet launch.
Exactly.
Wow.
That's a concise way of putting it.
Okay, that's pretty good place to be.
That's a great place to be. Yes.
So if you you know the hill chart.
I don't know the hill chart.
So
Please enlighten me.
The hill chart is something that has been championed by the guys at 37 Signals, and it's a way to estimate how far along you are in a software project, whereby you admit that software projects are incredibly difficult to estimate. So instead of using like t-shirt sizes or whatever, they just draw a hill, and they say, are you like still climbing the hill where you're not sure where the end is, or like, are you on top of the hill where you still have a lot to do but you see where the end is, and you're like you're over the top. You're like coming down.
Yes, but I think maybe the word foothill is more appropriate, right? Because we're not including block consensus programs for launch, and that is going to be a big task still.
Okay.
But yeah, we're approaching a plateau prior to the next big stretch
Okay.
of
Now,
the
now you're
upwards journey.
complicating the hill. Now I don't know what it looks like anymore.
Yes, it's not a simple hill.
Okay. Is that a trade-off that you made this week? Because I don't remember that from our
The
previous conversation.
idea has been floating for a while, and we basically made the decision over the last few weeks. Yeah, but not more recently than that.
Okay, and so and just to make it concrete for the listeners and viewers, what kinds of things will you not be able to do until that gets released?
Um, the block consensus logic is mainly responsible for succinctness, which means that you can synchronize to the network with basically just reading the last block. The last block would contain a proof of correctness of all of history, and that proof is not going to be there. And so, if you want to synchronize to the network, you'll have to download all of history and verify all of history, which is not going to be a lot right after
Not going to
launch.
be a lot in the beginning, yeah.
Correct.
Okay, seems like a more than reasonable trade-off.
Hmm. And
Okay.
it's also boosting morale, I have to say, because now the journey doesn't seem so far anymore.
Postponing difficult things tends to do that. Ah, yes.
Yeah, but it's also giving us the opportunity to look back on the vertical meters that we have already covered.
Yeah, fair enough. Okay, cool. Anything else to mention from the last 2 weeks?
I can't think of anything at this point.
Okay, shall we do an early finish?
That sounds like the perfect point to finish early.
Okay,
All right,
cool.
take care. Bye
All
bye.
right, take care.